Good evening, friends. Let's take up the discussion on differentiation concepts. My name is Manjunath. Welcome you all to YouTube Academy classes. Today's discussion will be on three major areas. One is I shall be covering the differentiation various parameters. Number two, the formulas associated with differentiation. Number three, specific questions that have been reflected in CET papers from the chapter of differentiation. These are the three objectives I have kept. I welcome you all to this Unacademy session. And friends, Unacademy tries good experiments in focusing, in showcasing the various contents through educators like us. The best of best faculties from across the country will be part of this system, and their only motto would be to showcase you, to get you the right information at the right time in the right manner. Hope you all are enjoying this. I know we are running through a very difficult situation, but still, thanks to the systems like Unacademy, which has given enough space through distance education, through virtual education, to reach to all of you and to help you achieve your dreams, goals, and whatever the expectations you have kept. So with this brief intro, I would like to welcome you once again for this session on differentiation. Friends, as you know that if y be a continuous function of x, then dy by dx, where delta x tends to 0, do exist with the limiting value of delta x tends to 0, f of x plus dx plus minus f of x by dx. And this is called the derivative or the differential coefficient of f of x with respect to x. Second, if f dash a exists, then f of x is continuous at x equal to a, but the converse is not true. I would like to help you with an example. Mod x is continuous at x equal to 0, but not differentiable at x equal to 0. Let's go ahead looking at some more examples. Consider f of x is equal to x minus 2 mod x minus 2 and x is equal to 2 at x equal to 2. F dash of 2 plus 0 equals limit h tends to 0 f of 2 plus h minus f of 2 by h. Limit h tends to 0 mod h minus 0 by h, which is h by h equal to 1. Similarly, f dash of 2 minus 0, limit h tends to 0, h mod h by h is minus 1. Compare the two, left hand derivative and right hand derivative, they are not equal. So definitely f dash of 2 doesn't exist. One more, friends, consider x at x equal to 2. F dash of x 2 plus 0 is limit h tends to 0, 2 plus h minus 2 by h. The answer is limit h tends to 0, 2 minus 2 by h, which is 0. Similarly, f dash of 2 minus 0, limit h tends to 0, 2 plus h minus 2 by h. It is 1 minus 2. 1 minus 2 is minus 1 by 0, which is infinity. So f dash of 2 does not exist. So what can we say? F of x is not continuous at x equal to 2. Friends, I have one more very interesting. The function represented by the following graph. I want you to check out what is the right answer here. Look at the graph. There is a sharp edge at x equal to 1. Therefore, it is not differentiable at x equal to 1. Definitely, you can see continuity in this. So, what is the answer? It's not 3. 3 is actually wrong here. It is 1. It is continuous but not differentiable at x equal to 1. Friends, let me take you into some more concepts. Which of the following is not true always? 4 options are there. Please have a glance on it. Yes, you are absolutely right. Third is not true. If f of x is continuous at x equal to a, then it is differentiable at x equal to a. Let me go ahead with one more. The domain of a derivative of function f of x equals x square minus 1 by x minus 1, where x is less than or equal to 0, and one more, 1 plus 2x, where x is greater than 0 is. Let's see how it can be handled. F of x is, if I take x plus 1, where x is less than or equal to 0. Why it is x plus 1? Please see there. X square minus 1 can be written as x minus 1 into x plus 1 by x minus 1. Remove these two. You get x plus 1. So f of x is equal to x plus 1, where x is less than or equal to 0, and f of x is 1 plus 2x, where x is greater than 0. Friends, at x equal to 0, the left hand derivative is 1. Look at this. At x equal to 0, the left hand derivative is 1, and at right hand derivative, this will be 0. 2 into 1 is 2. There's 2. So f dash of 0 doesn't exist. Am I right? F dash of 0, it does not exist. And f dash of x, definitely it exists for all values where x is not equal to 0. So the right answer is r minus 0. Friends, I'll take you into another problem. f of x is equal to sine of pi minus into x minus pi by 1 plus x the whole square, where what denotes the greater integer function. Then which of the following is true? Solution is there for you for the support. Please have a glance at it. So x minus pi is an integer here. Therefore, sine of pi into x minus pi, which is sine of n pi, where n is an integer. Therefore, what I can say, f of x is equal to 0 for all values of x. And if you differentiate, f dash of x is also equal to 0 for all values of x. So the right answer is f of x is differentiable for all values of x. One more. Let f of x is equal to, the maximum values are x square and x power 4. Then f of x is not differentiable at look at that solution, x square and x power 4. Square and x power 4. When you differentiate it, it becomes 2x and 4x cube. So f dash of x, if f of x is lying between -1 and 1, f dash of x does not exist as -1 and 1. And f dash of 0 is equal to 0. So what is the right option here? They are not differentiable at x equals to plus or minus 1, between -1 and +1. For what value or values of the constant k is the function f of x equals sine 2x, where x is less than 0, and it is equal to kx, where x is greater than 0. Now you need to answer this at 2 points. A, continuous at x equal to 0. B, differentiable at x equal to 0. If f of 0 is equal to 0, limit extends to 0, f of x is equal to 0, limit extends to 0, k into x, k is any real number. F of x is continuous for all k belongs to R. F dash of x is equal to 2 cos 2x, whereas x is less than 0, and f dash of x is equal to k, where x is greater than 0. If f dash of x will exist as 2 cos theta, which is equal to k, 2 cos 0 it is actually. 2 into 0 is 0, 2 cos 0, and cos 0 is 1, therefore k is going to be equal to 2. So we have second one as the option, k belongs to R and k equal to 2 for the two conditions. Friends, let me take you into another journey where I said you will be introduced to some of the formulas. Till now you saw how differentiation is applied. Now you're going to see some of the rules of differentiation. If y equals ku, dy by dx is equal to k into du by dx. Please understand, u, v, y are the functions of x and k is constant. If y equals u plus or minus v, dy by dx is equal to du by dx plus or minus dv by dx. Friends, there is one beautiful example which is taken from CET 2014 for your illustration. Please have a look at it. F of x is given as x power 100 by 100, x power 99 by 99 goes as x power 2 by 2 plus x plus 1. Then f dash of 0 is what? See, f dash of x will be 100 into n into formula power n minus 1. 100 into 100 power x power 100 minus 1, which will be 99, divided by 100. So 100 cancels, you will have x power 99, x power 98, like that. And last is x square is 2x, which is going to be 2 cancels, it is going to be x. And finally, x differentiation is 1. So friends, into this substitute f dash of 0. Wherever there is x, you will get it as 0. X differentiation is 1, that will only remain. And 1 differentiation, actually it is constant, so it becomes 0. So only 1 remains. The whole answer for this sum is 1. Next one, product rule. We have two functions which are multiplied, u and v, and when you differentiate the product of these two functions, how it will be differentiated? If y is equal to uv, dy by dx equals v into du by dx plus u into dv by dx. Second function into differentiation of first plus first into differentiation of second. Similarly, when you take three functions, first differentiation into the product of other two, second differentiation into product of first and third differentiation into product of first and second. U dash into VW plus V dash into UW plus UV into W dash. This is product rule. Next one, quotient rule. When you have two functions which are divided by each other, u by v, y equals u by v, differentiation dy by dx equal to v into du by dx minus u into dv by dx whole divided by v square. In a simple format, it can be written v minus into u dash minus u into v dash by v square. That is quotient rule. Third one, chain rule. Function of a function. They give composite functions. One function inside the other. Then you differentiate the first larger function. Then you proceed towards the minor ones. Log of sin x. First you take the log, that is differentiated, then you differentiate the sign. If log of sine of root x, first log, then sine, then root x, like that. So this is chain rule. Y equals f of u, then dy by dx equal to f dash of u into du by dx. Next, dy by dx equals 1 divided by dx by dy. Very important. Friends, I have set of formulas of differentiation. This is what should be known to you perfectly. If this is known, I can tell you, you know differentiation perfectly. There are 4 columns in this, friends. First 2 columns talk about the function and its differentiation. Second, third and fourth column talks about the chain rule concept in the same function. Suppose y is equal to f of x, like y is constant. What is its differentiation? It is 0. Is this clear? Constant differentiation is 0. Chain rule, you can't do anything like that because constant itself 0, you can't proceed further. Next, x power n. We just now saw this formula in the previous sums solving. X power n is n into x power n minus 1. Same thing if I take it in terms of something else like sine power 2x or sine power x, log power log 3x, something like this. This is, then when I do this, n into u power n minus 1, sine square x, if I say, it will be 2 sine x first of all, then differentiation of sine x. Differentiation of sine x will be cos x. Like if I say a square will be 2a and a is differentiation. 2a into dA by dx. Function of a function here. In first case it is direct. Differentiation of x. Here differentiation of u, then differentiation with respect to x. Root x, 1 by 2 root x. Root u, root of cos x, let me say. It is first 1 by 2 root of cos x, because root x concept. Then cos x differentiation, that will be minus sin x, du by dx. So root u is 1 by 2 root u into du by dx. Next, 1 by x, it's minus 1 by x square. 1 by u, minus 1 by u square into du by dx. 1 by x power n, minus n by x power n plus 1. 1 by u power n minus n by u power n plus 1 into du by dx. Further, friends, on trigonometric functions, these are all very, very important questions and you get quite a lot from this particular area. Sine x, it is cos x. Sine u, if I say here sine a square, if I say first differentiation of sine a square, it will be cos a square and then a square's differentiation to a. Like that. Sine 2x, it can be written as 2 sine x cos x. Then 2 you keep it as it is. Sine x and cos x you have to, UV method you need to adopt over there. Cos x, which is minus sine x. cos u minus sin u into du by dx. Tan x secant square x, cot x minus cosecant square x, secant x tan x, cosecant x minus cosecant x cot x. Further, sin inverse x 1 by root of 1 minus x square, cos inverse x minus 1 by root of 1 minus x square, tan inverse x 1 by 1 plus x square, cot inverse x minus 1 by 1 plus x square, secant inverse x 1 by x into root of x square minus 1, cosecant inverse x minus 1 by x into root of x square minus 1. If y is a power x, then dy by dx is a power x log a. If y is e power x, dy by dx is e power x. If y is log x, dy by dx is 1 by x. Y is x to log a base. If it is, please see that it is 1 by x into log e to base a. These are all some of the formulas that we need to remember. Friends, let me take you into the journey of problems now. Now, these formulas you must know perfectly. There are around 22 formulas that you must practice perfectly. If this is known to you, as I said, you know differentiation very well. Okay, now let's get into the examples. Differentiation of 2 power minus x. It's like a power x. What is a power x? A power x into log a. So 2 power minus x is 2 power minus x into log 2, and differentiation of minus x, which will be minus 1. So altogether the answer is minus 2. You should not forget this. Purposefully they give you two options, friend. One is 2 power minus x into log 2. Another one minus 2 power minus x log 2. And if you take the first one, you are wrong. Minus 2 power, because differentiation of minus x is minus 1. So minus 1 into this value is minus 2. Okay. Differentiation of root cot x. 1 by 2 root cot x. Why? Root x differentiation it is. 1 by 2 root x. And differentiation of cot x is minus cos x square x. So the final answer is minus cos x square x by 2 root of cot x. Third one, look here, tan inverse of 3x. We know tan inverse x is 1 by 1 plus x square. Now x is 3x here. So 3x the whole square is 9x square, and then 3x differentiation is 3. So 3 by 1 plus 9x square. Tan inverse of e power x. dy by dx is 1 by 1 plus e power x the whole square into e power x. So it is e power x by 1 plus e power 2x. Here also, friends, purposefully you will be given the first option as e power x by 1 plus e power x. And if you don't see that 2 and just tick that, you have lost marks. These are all small things that we need to be taking care while answering. Cot inverse of x square. You need to differentiate for cot first, cot inverse first, and then x square. Cot inverse differentiation is cot inverse x is minus 1 by 1 plus x square. So for the x, substitute x square. So x square whole square is x power 4. Now x square differentiation is 2x. So the final answer is minus 2x by 1 plus x power 4. Hope the concepts are clear to you. So I am proceeding further. Y is equal to cos square root x. First friends, this looks like x square. So x square differentiation is 2x. So it is 2 cos root x is the first answer. X square differentiation we have done it as 2 cos root x. Now cos x differentiation. What is cos x differentiation? Minus sine root x. Cos differentiation is minus sine root x. Third is root x differentiation 1 by 2 root x. All the three put together, it is minus sine 2 root x. Why you see here? It is sine 2 into cos root x into sine 2 theta. 2 sine theta into cos theta. This is the answer. So minus sine 2 root x, y minus, it's minus 1 minus is here, divided by 2 root. Friends, please don't go for cancelling these. They cannot be. Don't make this kind of, purposefully they give you this kind of answers. Don't get into such mistakes. It's a very silly mistakes if we do all that. Next one, cos of log sine x. Cos of log sine x. See, first function, second and third. There are three. So what is differentiation of cos? Minus sine. Minus sine x. Minus sine into log of sine x, like that. Now next is log sine x differentiation. What is log sine x differentiation? 1 by sine x. Log is 1 by x. So 1 by sine x differentiation. Into sine x differentiation is cos x. Now cos x by sine x is cot x. Minus is here. The same minus is kept. And rest is sine of log sine x. Is this clear? Minus cot x into sine of log sine x. One more. Log of tan root x. Again we have 3. First log 1 by x. Log x is 1 by x. So it is 1 by tan root x. Now tan differentiation. Tan differentiation is secant square x. This is first. This is second. And we have third here. Third is root x differentiation. 1 by 2 root x. What is the final answer? 1 by tan root x into secant square root x into 1 by 2 root x. Hope this concept is very clear to you, friends. I have another interesting sum here. Y equals e power log x by x into log of e power 1 plus tan x. Now, log of e power this 1 plus tan x, you take it as u. Now, log of e power u, this is log of e power u. What is log of e power u? Equals u into log e to base e. So it is u. Log e to base e is 1. So we got it as 1, u. Similarly, this also, take it as e power log u. E power log u. E power log u is again u. E power log u equals u. In that manner, here e power log x is x by x. These two cancels, and log e power 1 plus tan x is 1 plus tan x. So finally, y is equal to 1 plus tan x. When you differentiate this, 1 is 0. Tan x differentiation is 6 square x. So the answer for this is secant square x. Next, secant y equals secant inverse of x square plus 4 by x square plus 1 plus cosecant inverse of x square plus 4 by x square plus 1. Find dy by dx. See friends, it looks like y equals secant inverse x plus cosecant inverse x. What do we know about these two? Secant inverse x plus cosecant inverse x is pi by 2. If y is pi by 2, differentiation of this is constant, which will be 0. Hope you got that concept clearly. Next, friends, let's not hurry up. I want you to know this concepts very clearly. See, here in this, if I don't know the concept between secant inverse x plus cosecant inverse x is pi by 2, I can't solve that sum. Let's not get into like there is one composite secant inverse differentiation, then doing that x squared by plus 4 by x square plus 1 u by v method. If you go on applying the whole CET, you will solve only one sum. You must know the formulas at the right juncture and you must adopt. See, such a big sum, it looks like how simple the answer is. This is exactly what I am trying to look at. What is that? My focus here is you need to connect the formulas. Secant inverse x plus cosecant inverse x is pi by 2. If this concept strikes to you, the sum is done. Next one, please have a look at it. Y equals x into tan of x by 2. We have two functions here, friends. Y equals uv. It is u into v dash plus v into u dash. So tan x by 2 into x differentiation is 1 plus x into tan x by 2 differentiation is secant square x by 2 into 1 by 2. This is important. In a hurry, we should not leave that. Don't just convert tan x by 2 as secant square x by 2 and proceed. Then the whole sum will go wrong. Now, rest is just mere calculations. Here, tan x by 2 is converted as sin x by 2 by cos x by 2. Tan x by 2 is written as sin x by 2 by cos x by 2 plus half into x into secant square x by 2 is written as 1 by cos square x by 2. Why this is done is so that in both the denominators you have cos x by 2, you can equate it. Now here you have 2 cos square x by 2, here you have cos x by 2. Take 2 cos square x by 2 as the common factor. Then 2 into sin x by 2 into cos x by 2 you get here in the numerator plus x. Okay, this is again the half angle formula for sine 2 theta, which is sin x plus x by 1 plus cos x. This is what you need. Friends, this, if you understand thoroughly, see what all we have done in this, we have adopted first product formula. Once and that too in product formula, see, as I said, this area is very, very important. Tan x by 2, if you have differentiated, it becomes secant square x by 2 into half, because that half is constant over there. You can write first 1 by 2 into secant square x by 2 also you can write it. Okay. But you should not forget it. Rest is simple calculation. Hope I am not very fast. My only concern is I just want to solve as many sums as possible and make you enjoy this differentiation. Say differentiation is one such chapter where if the formulas are known to us, if the concepts are known to us, if we connect these two things, formulas are needed. Mathematics, see, rest all maths chapters are connected here with their formulas, and differentiation formulas, the 22 formulas what you learned over there. These two, if you integrate, differentiation is here. See, the next one is y is equal to log x by x. Y is equal to u by v method. V into u dash minus u into v dash by v square. And after you get it, you need to substitute for differentiated value x as equal to e. What did we do? X, so v into u dash. V is x, u is log x, so x into 1 by x. Log x is 1 by x differentiation. Minus log x into differentiation of x is 1 divided by x square. See friends, these two cancels. 1 minus log x by x square. And for x you substitute e. 1 minus log e by e square. What is log e equal to? 1. So 1 minus 1 is 0 by e square. 0 is the answer. Next, y equals log of cos root x. Y equals log of cos root x. 3 functions are here. Now, what is log? 1 by cos of root x. What is cos? Minus sine root x. What is root x? 1 by 2 root x. So what did we get, friends? Minus sine root x by cos root x is minus tan root x divided by 2 root x. So minus tan root x by 2 root x is the right answer. Hope these concepts are very clear to you, and you must understand this clearly. See if I can do systematically. First log differentiation, then cos differentiation, then root x differentiation. You get the answer. That's why the chain rule means the function of a function, you go on substituting, but you have to go from outward to inward. Don't come in the opposite direction. Okay. Next. This is a sum which you have already done it, but you need to little think here while doing this sum. Y equals secant inverse of root x minus 1 by x plus root x plus sine inverse of x plus root x by root x minus 1. See friends, this is secant inverse x, this is sine inverse, but this is secant inverse 1 by x. Can I write that as cos inverse x? Just see. Is cos inverse x equal to secant inverse of 1 by x? Let's have a look at the formula if there is any confusion. See, this is secant inverse x. This is cos inverse x. Differentiation. My question is not this. My question is cos inverse x equal to secant inverse of secant inverse of 1 by x? How do we get to know? Take secant inverse x as equal to theta, secant theta equals x, 1 by cos theta equals x. Now cos theta is what? Cos theta equals 1 by x. So this is cos inverse 1 by x. That's exactly what you have done. Now if I have to convert this as cos inverse of x plus root x by root x minus 1, x plus root x by root x minus 1, this is cos and this is sine. So as I said earlier, what is that formula we know? Cos inverse x plus sine inverse x is pi by 2, and y equals pi by 2. Differentiation of pi by 2 is 0. This is how you must get it, friends. Hope this concept is clear. See, this first part you must know very well. Secant inverse of x is cos inverse of 1 by x. If this strikes to your mind, then the whole sum becomes a very simplified answer. Other than that, if you go for doing anything else, it becomes a nonsense for us and a huge complication it creates. Any doubts? Okay, let's move into one more very interesting one. Y equals secant x plus tan x by secant x minus tan x. Y equals secant x plus tan x by secant x minus tan x. What is dy by dx equal to? See friends, this need to be rationalized. And 1 by secant x minus tan x is secant x plus tan x. How did we get it? Secant x plus tan x divided by into secant x plus tan x by secant x plus tan x you did. This is equal to secant x plus tan x divided by secant x plus tan x into secant x minus tan x is secant square x minus tan square x, which is 1. So the numerator secant x plus tan x into, you have 1 secant x plus tan x in the numerator here. So it is secant x plus tan x whole square. Now this looks like x square. X square differentiation is 2x. 2x differentiation, 2 into secant x plus tan x. Then each one of their differentiation. Secant x differentiation is secant x tan x and tan x differentiation is secant square x. In the second, take secant x common. 2 into secant x into secant x plus tan x the whole square is the answer. I hope the concepts are very, very clear to your mind. See, we did what? First is rationalization. Denominator and numerator. You need to see, because the whole answers, see, this is the second answer that is right. Oh, sorry. 2 secant x. Yeah, it's not 2, it is third one. Two secant x into secant x plus tan x the whole square. This is what I always tell. Even a small error can take you in the wrong direction. Okay. How is this correct? First, rationalize the denominator. Once you rationalize, see, the sum becomes perfect. And it is simple and it is easy to. You must correlate the answer and see how the process need to be taken care. That's how you must achieve the results here. Clear? I have one more. This question had come. See, all these questions what I am giving you are from various CET papers and all. This was asked in one of the IIT papers. F dash of x is equal to sine x square and y equals f of x square plus 1. Find dy by dx. If y is f of x square plus 1 and f dash of x is sine x square, then what is dy by dx equal to? Dy by dx is f dash of this into x square differentiation is 2x. F dash of this is the differentiation of this and x square differentiation is 2x. Now see friends, what is f dash of x according to them? It is sine x square. So substitute it here. Sine of x square plus 1 the whole square. Why it is x square plus 1 the whole square? It is x square. Sine x square f dash of x is into the 2x which was there in this sum. This is the answer. Hope this concept is clear to your mind. They have given f dash of x as some value. They have given a y function and they have asked you to differentiate it. So y, when you differentiate this, it is f dash of x square plus 1 into x square's differentiation is 2x. Correct? See, sine of x square plus 1, if they have given, it will be cos x square plus 1, and differentiation of x square and 1. X square will be 2x, 1 will be 0. So 2x is the value that needs to be taken along. That's how it is. And later, f dash of x, which is given as sine x square, to be substituted into it. Okay. Third, next, very beautiful sum. It's very unique. See here, they have given a determinant and they have set p as constant. The third row values are constant. Second row, anyhow, it is all constant values. We don't have to touch these two. The variables are only in the first row. Now, this has to be differentiated 3 times. 1, 2, 3. F triple dash 0 you need to calculate. That means do the differentiation 3 times and then substitute the value of 0 in it. That means the determinant becomes 0 at the third differentiation is the concept. And its answer need to be 0 then. Okay. First differentiation, x cube becomes 3x square. Sine x becomes cos x. Cos x becomes minus sine x. Second and third row, I'm not speaking at all because we don't have to look at it. Second time when I differentiate, 3x square becomes 6x, 3 2s are 6, correct? Sine cos x becomes minus sine x, and minus sine x becomes minus, will remain as it is, sine becomes cos, so minus cos x. In the third differentiation, 6x, if you differentiate it is 6, minus sine x, if you differentiate, minus will remain as it is, sine x differentiation is cos x. And minus cos x, minus will be as it is, cos x differentiation is minus sine x, minus into minus becomes plus. This is the thing. Now, into this, put the value of x as 0. Cos 0 is how much? Minus, it is 1. Minus into 1 is minus 1. Sine 0 is 0, it is 0. So first row became 6 minus 1 0, second row became 6 minus 1 0. And we know that when two rows are identical in any determinant, its value is 0. So f triple dash will be 0, friends. So very unique. According to me, this kind of sums you must attempt. Only the thing is you must get the idea. See, 3 times doing the differentiation without tapping the second and third rows, and you must guess and get to know that if the 2 rows can be identical and substituting the value of 0 into it, then the determinant can be 0. Very unique ones, friends. Next one, derivative of sine x degrees into cos x with respect to x. One is in degrees, another one in radians, friends. Here you need to be careful. So first, x degrees can be converted into radians, pi by 180 into x radians. Put that into the sum. Sine of pi by 180 into x into cos x. Now uv method, u into v dash plus v into u dash. When cos x into, if you differentiate this, pi by 180 constant comes out, sine will become cos of pi by 180 x into cos x. Plus sine of pi x by 180 into cos x differentiation is minus sine x. Convert back this into degrees. This we had done for our simplification. So as to get the right answer, pi by 180 into cos x degrees into cos x minus sine x degrees into sine x. So the right answer is second one. Look at the last one. This is an interesting question that need to be planned out. F of x plus y is equal to f of x plus f of y for all values of x and y which belongs to R. If x is differentiable at x equal to 0 for this function, what are the answers? One is f of x is continuous for all values of x belongs to R. Number 2, f dash of x is constant for all values of x belongs to R. This question comes under IIT group of questions where more than one answer will be correct. So under that category, these questions comes. I hope friends, you all have enjoyed the concept of differentiation. Our only experiment here is to make you enjoy, understand and get to know more about differentiations or any concept that we teach. So Unacademy's constant efforts through various educators is only this, that we satisfy each and every student who come and tap the doors of us. I wish every one of you who are using our platform all the very best. Please go to our sites, subscribe if you have not subscribed this, like the classes by pressing the like button and enjoy our session. All the very best to you. This is Manjunath signing off. Thank you very much.